Okay, I think we're gonna start up again. We're gonna be demoing with Brooks Oliver. I'll do a little intro. Brooks is over there. He's gonna do a talk at 4 o'clock, like an official talk, a formal talk. Cool. So I think the idea for this demo, Grant and I are gonna generate a form that we talked about earlier and cast it. And while it's drying, we might do a little software demo, and Brooks is just gonna work. Yeah. Cool. So, okay, so the first thing we're going to do is we kind of wrote this little Grasshopper definition. This is the definition. It's not very big. But it basically takes in all of the forms that we made and throws them up in a kind of hexagonal cylinder. Yikes. And then I have this little random number jitterer. It just like randomly kind of goes through this list. And so I have the seed that I can change and just generate a bunch of different forms. So we are on number 5, I think, even though I think I started at 2, maybe. So we're at number 5. So this is this form. So we're going to be making that form, which is a little bit hard to see. But then we have a little labeling system. So I'm going to kind of yell it out to Grant. He's going to find all the pieces, or I'll help him find the pieces. The way I have it labeled is this is kind of the bottom one all the way around, and then the next level up, and then the next level up. So we can start with SO6, smooth out 6. This might be a little boring if Brooks wanted to talk. We're just going to like FO4. Or I guess we can look at it. Okay. FI3 is the next one.
What, SI3?
FI3. And then FI5.
You say SI or FI?
FI, sorry.
Oh.
F.
FI5?
Mm-hmm. And then SO3. And then SO2. And then SO6, actually, if you want to grab them all.
I don't know.
6.
6?
Yeah.
And we're missing one then.
Oh, I'm back to the beginning. Then what did I miss? How did I miss? FO4, FI5.
SO3?
FI3, I'm sorry.
FI.
FI3 goes, I'm sorry, we're messing this up. It goes right there.
Okay.
Okay, cool. And then I'll go get the next one, and Grant will cinch that up. And there's no keys or anything. We're just kind of using those hold strap holders that we did. This is also our coddle system, if anyone wants to come see. So we laser cut this out and glued it all together, and then we even like laser cut out little peg holes, and then our little 3D printed piece locks right in there, and we just poured plaster over it and put a lot of Vaseline, and it came right out. Okay, so I'm going to get the next one. SI6, SO5.
Get this hair out of the way.
Okay, so where did you start?
I don't know. Just make up. There you go. Yeah.
SI6, SO5, SO5. Oh, not this one, sorry.
There you go.
There we go, we got it. Brooks, what are you doing?
Oh, sweet. I was going to say. By the way, I'm Brooks Oliver. I'm a resident at the R.G. Bray Foundation. Thanks all for being here. And again, my talk's at 4. But I work a lot with clay tools. How's that sounding? Pretty good? Okay. I work a lot with clay tools. In the 3D printer, I design and print specialized tools to help me make whatever form it is that I'm working on. Whether that's actually printing the prototype or printing specific scaffolding, or more recently making kind of more familiar ceramic tools, whether it's like a texturized rolling pin or stamps or extrusion dies. But just to kind of give an example, I cast a slab earlier that had some texturized, that had some colored grog in it. I just used the cookie cutter to stamp out the form. I just applied it to the mold, and I'm just going to slip cast it. So I'm going to assemble up the mold, pour in the slip, and then I'm going to start working on assembling another form. But yeah. I've been working with CAD now as like a way of sketching and my, essentially having a virtual sketchbook for like 7 years. And it's only been in the past like 4 years that I've had access to like 3D printers and CNC mills. Do any of you guys work with CAD and don't have like a 3D printer? No, everyone has a 3D printer, or is this, who has a 3D printer in here? Sweet, okay. So do you guys work with CAD, I assume? Okay, cool, sweet. Just silence. We're good, okay, thanks. But yeah, I'm just gonna pour this real quick.
God, yes.
Kind of get that going. And I would usually sieve this. Of course, I forgot my sieve.
Do you need a sieve?
It's okay, I'm not gonna take this home. No use of getting this back to Helena, Montana. I'll just make a new one.
We're gonna pit fire these outside.
Oh, totally.
Grant and I are showing our work at mid-semester critique in
Oh.
3 days. This is it.
This is
This is all we've been doing.
Thank you, NCECA.
So I'll start assembling this piece, but this is a piece I made. I call it the stem vase. It was designed to be a vase that you could see the entirety of a flower. My work is kind of about reimagining function to a degree and the familiar ceramic object. But with this piece, I originally started by printing out the 3 different components to it on my 3D printer. And I printed them all with the wells attached to them for the slip casting process. I really hate making plaster molds. It's a total mean to an ends for me. I love what molds do, but I hate making them. So anything I can do to make my life easier, I jump on that. So like this is, obviously the ring form with the wells printed on it. Same thing with the base. And the thing with this is once I cast all these pieces, I have no way of essentially assembling them all together unless, I have like 3 other people in the studio with me and I don't have the money to pay 3 other people. So I designed this, this assembly cradle. So essentially I do everything in Rhino, but I took this form, I essentially made this and I subtracted this from it, and this is fully fired, so it shrank. But so this essentially holds the 3 different components together while I assemble it. So I'm just gonna start working on that, and I assemble it upside down.
Yeah.
If I were to do it right side up, the weight of this tubing will slightly distort this, and that will just become a bit more amplified in the final firing. So yeah, I assemble it upside down, but essentially. Everything just kind of sits together like so.
Oh, we forgot the thing.
Oh, yeah.
And also, I don't know how you guys feel over there, but if you guys have like any questions, just please like yell them out or comments or concerns.
We're just ratcheting our mold together over here. Kind of.
I'm curious.
Yeah, so where this is just for the vertical tension.
Nice.
Yeah, just to protect the plaster. Yeah,
Oh,
we
what's
have a
that?
little wooden piece on
Oh.
top to protect our
It also
plaster.
helps, yeah.
It gives it tension. We also were gonna maybe try to clamp it with like vertical clamps this way, so we made a little base to do that.
We're learning.
We're learning, we're figuring
We're
it out.
improvising.
Okay, should we fill it up?
Let's do it.
We're just gonna fill this up with slip. Yeah, if you guys have any questions for us too, just yell them out. Need help?
I just want to make sure I don't tip it over.
Yeah, don't tip over the slip bucket.
So did you guys see how they made this mold? Was anyone here for their presentation a little bit earlier? Yeah? Yes? No? No? Do you guys want to explain that again? I thought it was really cool, not to
Yeah, we can
make you
explain briefly. We
redo that,
basically made like a custom caudal system because we knew we wanted kind of a hexagonal shape, and so we knew the angle of what our parting planes needed to be essentially. And if we knew we made them flat, that they could fit together with no keys. And so we made a little custom caudal system and printed out these little black things, and they turned into the the void that then holds our mold straps, and poured plaster in here, dammed it up with a bunch of clay, poured plaster, and then we threw this whole thing on the CNC mill and milled 6 at once all together to kind of save ourselves a lot of time and work.
As a side note, that's so cool. You can like mill plaster. That is something like
It's awesome.
where I went to school that was like
Yeah.
not super kosher.
Yeah.
Yeah, we were.
I'm not
allowed.
sure how much longer.
Scott might.
So you guys might have been the first and the last.
Yeah,
That's fair.
but it's pretty sweet.
It is very.
Yes, for sure. How long does it take you to clean the mill after you do that?
A good chunk of time. I've started like if it's little things, I'll like I took like an old sanding belt and just like put it as a little fence around my piece because basically it's just like the router bit like spins plaster everywhere essentially. And so it's more just a pain because it's like our mill is kind of close to the wall, so it's more like trying to engineer the shop vac to get in the crevices than anything.
Yeah.
We mill wet.
Yes,
because
absolutely.
Of dust, yeah.
Yes.
So it like chips off in little bits. It just chips a lot of bits off. Okay, I might run through a little bit of a grasshopper if anyone is interested. That's going to happen on one of these screens. So I'm going to run through the definition. Let me move these guys over a little bit. I'm going to run through the definition that I wrote that basically built just the in and the out of those curves. So it's a pretty straightforward.
Was anyone here not from our talk to kind of know what Grasshopper is?
Grasshopper is a plugin for Rhino. So this is the Rhino space, and so it has X, Y, Z coordinates. And again, for me, I have this math background, so when I learned about Rhino, it made complete sense to me because it was like, oh, this is like calculus. Like I know how to deal with these coordinates. But it's just 3-dimensional space that we're living in. But basically, so I'm going to just kind of run you guys through my definition. Everything is gray in this definition over there, and that means it's unpreviewed, so you can't see anything. So what I'm going to do is I'm just going to kind of run through it as if I were building it afresh, and I'll preview things and then unpreview them so we can kind of build it together. So basically, the first thing I did was I thought about, okay, I want a square, and I kind of want to push it out. And it's like, physically, I just want it to be like a piece of fabric and like bend it, or like a piece of rubber and just kind of push it out. But what does that mean? And this is where like Grasshopper comes in, like in Rhino too, like you have to start thinking about it in like, kind of like what Andy talked about yesterday morning, if any of you guys were there, like the computer doesn't understand that. Humans are way smarter, right? We just push it out and it goes. So we have to break it down into parameters. And so there's also like a gazillion ways of doing everything. But one way I thought that was really straightforward was like, okay, I know that in Rhino you can loft curves, which basically you can take curves and throw a surface kind of going through all of them. And so then I thought, okay, well, if I took 3 lines and put them right on top of each other and lofted those, that would be just a rectangle or a square. If I took that middle line and bent it out, then the loft between those would be a flat face, and then the middle would be bowed out. So that's essentially what I did. So I started with a point at the origin. So there's that red point there. And you can highlight it in Grasshopper, and it shows up in there. And then I moved a point just a certain distance away. And this one I moved it 4 inches. And so this is the awesome thing about Grasshopper is that there's sliders. So I can slide this, and if I wanted it 14.5 inches away, it is there now. And so I can just move it around. And I can go back once I'm further into my definition and move it back longer if I wanted to. But so then basically I did that, and then I made a line between them. It's a little bit hard to see, but there's that red line that's living there. So there's the line, and I can take away the points now. I don't really need to see those anymore. It's hard to see, but there's my line. And then I took it and I moved it. This is a Z vector, which means up, right? And this is just a little series thing. It's 3 different increments. And so I moved that line up 3 different increments. So there it is, and I don't need to see the bottom one. So I moved it 0, which is the same, and then by 2 inches, and then by 2 more inches, so up to 4 inches. So now this is my square face that I'm thinking about. And again, now this slider part is so cool. Like, because I started with just that line and moved it, now that when I make all of these bigger, they all go bigger and change together.
And that's why you want to use Grasshopper.
Because like I think I did make this at 5 inches, and we mocked it up, and we were like, oh, that's going to be a ton of plaster, and this thing is going to be huge. And so we were, let's just change it to 4, and it was like so simple to do. Whereas in Rhino, you can do it, but you have to be, smart about your workspace. Like oftentimes you forget to save things, and so then you only have your end product and you don't have all the steps in between.
Which is the worst.
Which is the worst, right? And so in Grasshopper,
All the time.
in Grasshopper, all the steps are there in between. And these don't actually live in Rhino. They're kind of these virtual things that are just in Grasshopper, and I get to choose when I want to make them put them in Rhino.
So can I ask?
Yeah.
Because I have no idea.
Yeah, sure.
So Grasshopper basically is giving you a map of the steps that you're.
A little bit, yeah. It's like I'm building in Grasshopper, and the
I'm coming
really
over here
great
to
thing
see
is
what you're doing.
you can import. So I could actually make a curve in Rhino. So that red curve lives in Rhino. I can select it. I can move it. I can do things to it, and then
What's
you can
that?
import back into
So that's the final piece.
into
These guys are all cast.
Grasshopper. So I can set one curve, and now this curve represents that curve. And if I move it, it's still doing this. So if I do things, I can now go back and forth too. So this definition I'm building entirely from Grasshopper with nothing in Rhino there. But you can go back and forth and set geometry and move it. So let's say I just wanted to do something simple like rotate one object, but I wanted to rotate it 100 times in a row, right? Well, I could sit there and click 100 times, and there's tricks you can do and click and move and do that. But in Grasshopper, I could set that one object to a little node in Grasshopper and do a rotate and you can make it go 100 times, and it'll just do it. And it'll rotate 100 times. And then if you decide, I wanted that to be 99 times, you just do a slider. Yeah, what do you,
I
Brooks
was
is using the
visiting
thing.
Brooks.
That's awesome. Do those things curve around the sides perfectly? Like cradle
They
it?
nest them,
That's
like,
awesome. Yeah,
perfectly.
that's
So by the
super
time
cool.
it's done drying, it just like pops right out.
Great.
So yeah, and it'll stiffen up in this as well.
Cool.
Of course, now that I'm demoing it, it's not fitting together just quite perfectly.
Well, of course.
You know.
The
like-
yellow, is that plastic?
Yeah,
You
so
printed that?
yeah, this is PLA. This was printed. So
Okay.
yeah, so again, these were the original prototypes. And then once I had those printed, I realized that I had no idea how to go about assembling this, and especially doing it in a really clean and easy manner. So I essentially just took the form, put it into Rhino, built this thing around it essentially, and then just Boolean. I don't know. Am I saying that correctly? Boolean.
Boolean?
Yeah, Boolean.
Union?
Okay.
Or
I'm
difference?
always- yeah.
Yeah.
The difference, essentially. So these curves hold these tubes only in one specific way. So if they wobble about a bit, I know that the form is probably going to warp in the final firing. So I kind of map everything out at first. And this is wobbling a bit.
I think this is the first time I've seen someone use the 3D printed plastic as like a structural, like a support
Yeah.
during the green state. Like, obviously it would be in the fired state, but
Yeah, right.
like I hadn't really thought of that before. Oh my
Yeah,
gosh.
it's a really, I don't know, it's just,
How did you come to that?
I don't know. I just, I've always been, I guess, somewhat of a problem solver. I studied engineering for like 3 years,
Okay.
and then switched my majors to art, which was a really fun conversation to have with my parents.
Sure.
As I'm sure some of us have been there. But yeah, you know, in my presentation, I'll go over like really specific tools that I've made, and I had this one piece where I couldn't get it out of the mold, again, because I didn't have like 7 hands. So I kind of made this this tool that had like was comprised of like string and hanging sponges, and it was all embedded on top of a milled CNC, a board that CNC milled these holes so that all the strings were just in the proper place. And I could insert the sponges into the form and then lift it up in unison. And I have a video. I mean, it's hard to talk about this tool, but you'll see it in my presentation if you decide to stay. But
You all must stay. You're not allowed to leave.
But yeah, so that was probably like the first tool I made. And then I just started realizing that with the 3D printer and within CAD, it was just so easy to take an extra step in the design process that would just make your life so much easier. And whether that's something so simple as like just printing the wells on the form, and also so your like wells
Yeah.
look really, really nice, which as a mold maker, it's so nice when just everything looks pretty. I am one of those people. Or if it's just making sure that something lines up properly, or more recently, I've been printing cradles for different forms. So like this is essentially what the final form will look like. It's part of this series, I call it the Wobble series. It's all about ceramics that can actually move. But I fired at cone 10. So this form would totally warp and distort at cone 10. So I make a cradle that fits the form perfectly. They're cast at the same time. They dry together, they fire together. My bisque goes to cone 10. And then I fire to 04 with a commercial glaze because those are all like deflocculated and have different gums in them. So it's really actually fairly easy to glaze a vitrified piece. And then I just stilt it up in the kiln. Other things, so this is like another one of those wobble pieces. It's a little wobble bowl. It's designed kind of just to rock back and forth. But I never actually had a prototype that looked like this. It was a lot easier. Again, I hate making molds, but I work with molds. So I divided the form up in CAD and essentially printed them on bases with their keys already registered on those. So essentially I printed a mother mold. So I put up the coddles or the walls around this, pour the plaster in, and then I have two perfect fitting mold pieces that just come together. And you know, versus taking something like this and building up the clay walls, and it's a way of, you know, eliminating time, essentially, which, you know, time is precious. So, yeah, so I've just been working with, like, creating different tools with the printer lately, and I had a great opportunity to do a workshop at the Manchester Craftsmen's Guild.
Where's that at?
It's in Pittsburgh.
Okay.
Excuse me. And they just finished building this state-of-the-art fab lab. It's truly incredible. They have 10 printers and a laser etcher. They don't have a CNC mill, but you know, they have like an incredible variety of printers. The most expensive of which is like, I think it's like 22,000. It's just It's one of those ones that just does everything.
Yeah.
And so they finished building this, and they wanted to incorporate it into with clay with their students, which are predominantly high school students. And so it was a 3-day workshop. In the first 2 days, I was teaching the kids how to use different CAD programs and just build simple clay tools that a lot of them were already familiar with. Whether it's like a texturized rolling pin. I mean, how many of us have, you know, rolled out a cylinder and just carved into it and, you know, essentially made a bisque texturized rolling pins. But, you know, it gave the students it gave them the option to get very specific. Like, I mean, for NCECA, I made an NCECA stamp, which, yeah. And, you know, different types of stamps. I made my own little initial stamp. We made a bunch of extrusion dies and cookie cutters, which aren't, you know, you can totally, I make my own cookie cutters for my cookies when I bake, but with the students, we were cutting out slabs and then laying those over hump molds and then smoothing the forms out, and that texture would remain on the inside. And then we'd like inlay that with underglaze. And it was great. So on the third day, we went to the clay studio and just played around. And it was so cool to see the students, they all just wanted to go directly back into the lab.
Yeah.
Because at that point, they had a different understanding. And I really like when working with these new technologies, or I guess I should say, I feel a lot of people look at this in a very linear way. That you design something on the computer, and then you like print a prototype, you make a mold, you have the clay piece, and it's done. But for me, I really enjoy when you start working with the clay, and that inherently just starts to go back into the design process. And you could see it with these students that once they started using this, they had all of these new ideas. And for me, that's pretty cool. That's what I like about this stuff, is when that dialogue is created instead of that like one-way conversation that I feel a lot of people that haven't worked with this technology might assume, I guess, for lack of a better example. But yeah.
Cool. Yeah.
And then I found $5. That's what I say when I don't know what to say next.
You found $5?
Not really. I
Oh.
wish.
I can take it over.
Yeah. How are you
Sweet,
doing?
go.
Yeah, I'll keep going on the Grasshopper. So I'm here, and I've made these. I kind of grabbed. So this one, I grabbed the the middle of those three lines. So I'll preview it. So I just grabbed the middle one because that was the one I wanted to bow out. And I took the 2 start lines, and then this little node is a catenary arch node. And this is, Grasshopper will ask you. So it asks for inputs. And a catenary arch, which is actually made from gravity, right? It's like if you take a string, it's the arch that's made when a string falls. So what this is asking me is the starting point, where am I holding it, the ending point, the length of my string, and then which direction do I want gravity to be. And that's what's awesome is gravity doesn't have to be down here. It doesn't even have to be at a right angle. It could be off in crazy directions. But for me, I just want to go kind of horizontal. So I'm going to go either in or out. And so gravity for me is this x vector here. And I can see if I get confused or lost, I have x, y, z little indicator down here, down in the corner. And okay, so then this series thing, that's just giving me a count of 6. So I'm actually moving, or this one is giving me a count of 6. So I'm moving that direction in 6. But you can see over here what this series is giving me is it's saying what's my start value, what's my step size over, and then how many times do I want to step over. So what my start value is, if my length is exactly the same as the length of this line that's right here, there will be no bend because there's no room for that string to move. So this is the plus. So it's that input is the length of that one, and then my starting input. So if I preview these, there are my 6 catenary arches. And so this is the length of the starting. How much extra do I want to start with? I think I ended up doing 0.05. We ended up, but I'll show you kind of the decision, right? And at first it's like, why did you start there? I don't know, I probably didn't start there, so we could start somewhere different. I didn't really know. And then the step size is how much more do I want my string to increase every time, the length of it. So I can make them do really big increases, or they can all be kind of on top of each other. So you can see that this one sets that beginning one, and then this guy sets kind of the difference between them. And so then now I have six things. I can unpreview this one to just see my catenary arches, and there they are. I think I have 6. 1, 2, 3, 4. I only have 5. How did that happen? I don't know. Because this number is only
Could you show everyone there so you can you can show the words for what those letters mean?
Oh yeah, I don't. How do you do that? Display, draw full names.
Yeah.
Oh, yeah.
I just want people to see how wonderful you can minimize all that stuff, but it does really start to explain what these things are.
And
Anyways.
it prompts you kind of it's
Yeah.
looking for this thing, so I go and find that thing.
Yeah.
And I had that set at 5, but I could have 7 curves or 8 curves or as many or as few as I want to. And these are the sliders. So we're going to do 6 because that's how many I want for this thing. And then I just have this wonderful loft. So these guys are, I made 6 copies of actually the top and the bottom curves so that I could then match up those 6 copies with my 6 catenary curves and loft them all together. And so then what happens here is I'm going to preview this guy. What's happening?
Can you explain what the dotted lines are as opposed to the straight lines?
Yeah, I mean, yes. And that's, I think, the hardest part for me about Grasshopper. So the dotted lines mean that information has been grafted. And I have grafted some of it, and some of it comes out grafted. And it has to do with kind of, if you haven't know matrices at all, it has a little bit to do with that. But the hardest part I find about Grasshopper is dealing with trees versus lists. So some things come in just lists, which I find easier to understand. If I flatten something, which now I can see, it's just a list of 6 polyline curves, right? But the way it came out of that before I had flattened it is they each are now in their own list. So now it's like 6 lists of 1 polyline curve each. And the reason I wanted to do that is because if I copy this panel and paste, and this is still something I really struggle with Grasshopper. It's I think the hardest part is organizing your lists. But now I made 6 copies of those lines and 6 copies of these lines. And so if I'll ungraft this and ungraft this one, and then and see how it doesn't want to loft it, because basically now it's trying to take all 6 of these lines and loft that with the first one, and then with all 6 of the other ones, because that's how it matches up. So when I graft it,
tell everyone what's the difference between like a tree and a list?
Yeah, well, that's kind of the difference between a tree and a list. So a tree has these different branches, and within each branch, it is a list. So you can think about it either like a matrix or a tree is what they're called. But I think it's a little bit easier. We can show this too, like how there's all these different ways of visualizing. So these yellow panels, that just shows the output. So now you can see with these three things, the output, it's now because it takes these indices. So now it's trying to loft the first thing in this one, the first branch in this tree, and the first branch in this tree, all of those three. Whereas if those trees and the structure of those trees or those matrices didn't match up, it would get confused about how do you want me to put this together. It's that same thing that Andy Brayman was talking about yesterday morning, where it's like, really, the computer isn't that smart. Like, we have to like dumb it down to this really simple level of how it can understand what's going on. Oops.
How you doing over there, Brooks?
Good. I was just, hallelujah.
Your
to that
phone's ringing,
last
Grant?
comment.
Do we want to wait? This is 18 minutes.
Your phone's ringing.
How long do we want to wait? Can we do 20?
We can wait 20 minutes.
Okay.
But anyway, so I can delete those. That's just like a helping me visualize. But then I can turn this guy on, preview, and there's all of my surfaces. And it's not super helpful to me because now there's like all on top of each other.
She's great.
And it's like, how the heck do I see that? How do I understand that? And for me, like, the reason I love Grasshopper with Rhino too is that this part kind of feeds that theoretical. And it's still things where I kind of guess. I'm like, I'm pretty sure if I do this, this thing is going to pop out. But I'm not 100% sure. And so it's like more than just text. But it's also more than just these nodes. It's like I immediately see what I did in a, not physical, but in a three-dimensional representation. So now we can unpreview all this stuff. Oops, I don't want to reverse that. Just unpreview it.
I'm going to be about ready to vacuum pretty soon.
Okay, yeah, I'm almost done. And then, so then the last thing I did was I said, oh, well, maybe I want to see what this mold actually looks like rotated in a hexagon. So why don't I just do that here before just like guessing what's going to happen? So then I rotated all of those and I can just unpreview those. And now what this did was it took all 6 of my outdents and rotated them around. And you can look at it and you're like, that's great, I did it. But maybe like you can now kind of test some physical limitations. So I was going to make some out ones, but I was also going to make some in ones. So I'll let the gravity, I just switched the direction of gravity to in. And you can zoom in now and see, oh, that's going to be a tight moment in my mold, right? If those two guys are together, like that might not want to cast well, if you think about what that is. Or even if I had upped those step sizes even more, you know, now they're actually running into each other. And that's like 2 plaster pieces knocking into each other as you try to put them. And so this is what I mean, is I just set these randomly, I think, when I built this mold. And then it was, or this definition. And then it was like, this is also too where like the collaboration came in, where I then grabbed Grant and I was like, okay, what do we want to do like practically? Okay, this has to go down, but also like aesthetically, like, and it was, Grant was like, oh, I think, you know, let's make the first one like really subtle, and then it'll go up and it'll just be this subtle step size. So that was where we decided this was going to be 0.05. And then it was like, that one still feels like too much. And then we were worrying about, is that going to suction out when we undo our molds? And so this is, and it's, you do have to kind of guess. It's hard to know before you see it all. But, you know, it's some decisions that you can make ahead of time. I think we ended up going 1/10 of an inch as the step size. And so then there it is. And then we were able to kind of look at it and see, oh, okay, cool. That's what maybe all the in ones. And does that seem like, could I cast that angle? Yeah, totally. That seems fine, and there it is. And then the last step we did was you take that, and this is all theoretical. I cannot select it or move it or do anything to it. And then there's a function called bake. And you bake it, and you could send it in. I'll send it into the default layer. And I bake, and now there's a physical representation that's overlaid on the kind of virtual, not physical. It's like physical in Rhino. It's
more physical than the Grasshopper.
The less virtual, I don't know. But the one I can select. And so now this one is one I can do things to, like we wanted to facet it. So I could take this and turn it into a mesh. So we turned it into a mesh object. And then we reduced the mesh size. So I can do mesh edit, reduce mesh, and we did like 256. So I reduced it into 256 polygons, and there it is. And so now that was how we got a mesh. And so now I can do some like Rhino physical manipulations to it.
I mean, when you render or model something in Rhino, you're modeling in what's called NURBS.
Yeah,
That's
NURB.
so maybe you could explain.
Yeah, NURBS, it's like the difference
NURBS
between
versus
mesh and NURBS. Meshes are points and flat faces, basically. And NURBS stands for something with B-splines, and it uses smooth curves to map things, is the way I think about it. I think about NURBS objects come with like longitude and latitude lines, basically. So like this, the longitude line, there's only one because it was made really simply, but because each of those curves was kind of complex, there's a lot of longitude lines that go and kind of map it together, and then some really smart programming goes and like smooths that out, so it's really, really smooth. And you can approximate a NURBS object with a mesh object. I could make that more. You know, we decided that we would like to reduce that mesh. You know, for our last one, I think we only had 16 polygons. So that was like a very fine mesh, and that's what you can see it on the base. Some of those look very faceted. And you can control that mesh and start to learn like how do I want to do that. You can start with just points and get to a mesh that way. You know, I'm sure in this room we could probably come up together with like 5 other ways I could have made that grasshopper definition other than those 3 curves. And that's, I think, one of the really awesome things about Rhino and Grasshopper, that there's just a lot of different ways to get to where you end. And then it can get more complex. So I'll just show you really quick.
Can I vacuum this out?
Oh yeah, okay, sorry.
It's gonna be loud.
I'll do that later. It's gonna be loud. Grant's gonna vacuum out our slip. Do you want me to hold the thing?
No.
Here, I'll put it on the ground. Oh, jeez.
Best trick ever. Don't have, like, everyone get this thing for like $20 to add it onto the bucket. Makes it like so much easier.
We're almost there. Oh,
We're good?
I need a little bit more.
Okay. Oh, isn't there a whole nother one? No.
Yeah, there's
There's like a whole nother thing.
You gonna do a dance?
I'm not gonna do a dance. Grant's gonna dance. Yeah.
We're good.
Yeah.
So kind of like I was talking about earlier, things are actually drying really quick in here, which has been really nice. But so when I assembled this, it wouldn't have been able to come out. But now it's dried ever so slightly, and the clay has shrunk up. So this can kind of just wobble out of here. And then I just have to clean up the top of the form. little areas that I couldn't get to otherwise. Also, mad props, Camille, for demoing Rhino and Grasshopper. That never works out when I do that, like ever. There's always some technical glitch.
Oh, thank you. Well, I teach math for a living, and so I'm used to looking at crowds with a lot of just like blank eyes. And the key is you find the one person that nods, and you just focus right in on them, and you're like, everyone gets
Okay, we got you.
this. This is
Yeah.
I'm such a good teacher. They all get
For
it.
sure. Man.
So are you using just the same casting slip to join the pieces together?
Just the same casting slip, and
Nice.
you know, it was so funny. I used to always have cracks when I would like score and slip things together that were cast. I don't know how I missed the memo. It's actually not great to score and slip. Yeah, I don't know how I missed that memo. So it's literally you just have to add slip. It's glue.
Yeah.
But yeah, and so I just kind of go back and forth, and it's a lot of like, you know, cleaning up. But I just want to make sure that everything is kind of well blended together. And usually I use those like mud tool sponges that like leave no residual sponging marks. Those things are the best.
What are you thinking about when you make these forms? Like, what's your...
I talk about my work as kind of a way of trying to reimagine the familiar functional vessel. I mean, I think it could be argued that the vessel is one of the most familiar things to a lot of people, just because, you know, of how we grow up with it. I grew up with China in my house, and yeah, it's just something that we're all familiar with. But when I think about it, I try to put a twist on it. So I want to present the viewer with something that's familiar and at the same time foreign. So whether it's, you know, a vase, which this is also kind of inspired by the martini glass. That's why I call it the stem vase.
Yeah.
But yeah, it's all about like presentation and display. But yeah, I wanted to make a vase that, you know, enabled the viewer to see and appreciate the entirety of a flower. It's just one of those things I've been working, or I had the opportunity to work with an Ikebana florist.
Oh.
And to hear them talk about the stem of the flower is something that, I don't know, I just had never really paid that much attention to. And so this kind of came out as a byproduct of that. And I usually pair this with another vase that is a large cylinder that has a thin slice through it. And it's a vase, the flowers, you have to look in to see them. Like, depending on how you approach it, you might not even recognize it as a vase. It's just like a tube. So there's also often this like moment of discovery, which I enjoy as well. Nice. But yeah, so I end up asking myself questions, I find, and that is what will oftentimes lead to a new idea. Like, you know, can a vase have a hole in it, and still contain something, or can a vessel be more of a line than it is something that actually has a mass to it? Can a vessel be playful? They're just these kind of constant questions that come into my mind, and yeah, I guess it's all about kind of reimagining something that's, you know, very familiar and that's kind of been around since the Earth has cooled, like literally.
Yeah. Those are really great questions. I'm trying to like.
So I'm just messing around on Grasshopper still
Need
over
some more
here.
meshing? What are we gonna do?
I don't know. I'm just kind of showing the Grasshopper definition. Like, this still is a relatively simple definition. Like, Joe was telling me he uses like so much, the whole space for definitions, and I've written longer ones too, but just how it can get a little bit more complex. So this whole definition, this is kind of a messy one, but this was how we made our caudal system. And so, you know, like, we did have one mess up where we had to redo a few of them.
You're not supposed to tell people this.
Sorry. It was true. But we also ran out of our wood. So we used a different kind of plywood, and our plywood was a slightly different thickness. And we talked about how, like, it was so important for us to model our caudal with the plaster in it exactly. And so if it was off a little bit, that would have been horrible. And if I had to go in and Rhino in every single one of those slats and make them slightly bigger, that would have been kind of miserable. So I wrote a definition where then, and then like the number of molds, like we only had to redo 3, so I hit it at 3. And then I went back and said, this one was only 0.201 or something. And so I do that, and then, and there's the thickness, and I have our little 3D printed things in there so we can see how it works. I can see we made little mortise and tenons, and they size accordingly. And so little things like that, like, the initial push to write this definition was probably a little bit longer, but then in a redo moment, it was very easy. Or, if I wanted to redo this project even slightly different, if I wanted to change that angle, those are all sliders that then can be changed.
I mean, with this, I think is an example, like this coddling system. If you guys were here for Camille and I's lecture earlier, and she showed her shelving, it's like the things that you learn, like you don't, I guess I would say like everything that you're sort of learning in Grasshopper that you can then apply to something else. You may not know what that's going to be, but it's okay to just sort of like have an idea and just go for it, and it doesn't have to be like, like the mind-blowing sort of thing. It can be like, and it will find its way in a future project.
Yeah.
It just kind of builds.
Totally.
So how do you break that down to an NCECA?
Yeah, totally. That's a great question. So I didn't write this into this definition because there's only really two shapes, because the two sides are the same shape, because I can flip the wood over, basically. And then each of those in-between ones, these guys are all the same shape too. So for me, this is like a moment where, we're kind of rushing to get this done, and it was like, okay, I could write into the definition, I lay it down flat, which I did when I made a big shelving system. It was in my definition that then it laid flat so that I didn't have to do all that clicking every single time. So you have to go find, and again, this is kind of not a very attractive definition, and it's a little bit disorganized, but you have to find the curves that you want to now have. And so again, I can't select any of these to do anything to them, but I know this is my little tenons, so I'm going to bake those guys. So I'll bake those, and then I'll go up to my rectangles. Let's see, which ones are those? Those are also the rectangles. I think it's these ones. No, maybe not. Oh yeah, those are those rectangles. I'll bake those. So you find the things that you want to then deal with. Those are the mortises. And then, let's see, I think it's this one. Maybe. And I'll go over here, and this is probably a curve I would like to deal with. I'll bake that. I think I have enough. Oh, that's not what I wanted. So I clicked the wrong one. What do I want to do?
You clicked the wrong one?
I clicked the wrong one. I know it never
It's not
happens to
confusing
you,
at
probably.
all. Like,
I know you've never clicked the wrong thing, and then something weird has blown up, and you're like, wait,
right? I don't understand.
hang on. I think
God,
that's
it's
what
like
I want. And again, like this is, if this was, I did this all in kind of one sitting. It was like quick. But I think I have now something there.
Oh, yeah.
Yeah,
Right.
so now I can select all that stuff and just move it away. And then now I have to figure out how to get these flat. And then this is where, again, just for me, the work to get it flat wasn't so bad. So I want to go and I want to select this side, and this is grouped, so I'll ungroup it. And then I want those little squares, those little mortises, they need to stay in the exact same spot, right? Because if I like grab this and move it and then try to move those rectangles, then nothing would line up. So those needed to stay in the same spot. So I'm going to select those, and I'll actually group all that together, and then I can move this. And I know I just want, oh, and I didn't do the circles, but I could have baked the circles. I want all of those guys to hang out. And then there's a way you can rotate. I can go into this viewport. And then I just want to take this object and I'm going to rotate it around. And this is the kind of like fluency where like I know where all the buttons are because I've clicked them many times. But that just comes with time. And now this is a flat thing down here. And then I just export this as an Illustrator file and send it right to our laser cutter. And then there's little things too, like when, Grant and I both learned this when we're making waffle structures and things like mortise and tenons that need to fit, that needs to be a right angle. And the laser cutter is awesome at that. It makes a right angle. The laser cutter is amazing. It's like the width of the laser is just enough to give it a little room to fit together. But when you go to a CNC machine, you have to do that manual offsetting, or you have to, figure out the CNC, if you're using a 1/4 inch router, will have a 1/4 inch rounded corner there. So you have to then problem solve and figure out how do you make that, act as a right angle. Like what are the solutions there? A lot of times you'll see little ears that come up here that make it a right angle, things like that. But yeah, that's a great question because you can totally get lost in Grasshopper forever and never go into. But Andy was showing yesterday things like there's things in Grasshopper that will bake. Baking is what brings them in. It'll bake things individually and label them for you. It not only will bake them, it might not even need to bake them. You can do plugins where it then just saves files. So you just click a button and it's like all your different objects. So if I was smart, it'd be like horizontal ones saved in a file. I just send it to the laser cutter. Then the vertical ones saved in a different file with a different name. So you can get and Andy was talking about, he was cutting those slabs. If he's cutting 1,000 of them, you could totally see why that was helpful. I had 2 different shapes, so for me it was like, just grab them and move them. Yeah, this is just like 1/8 inch or 1/4 inch plywood, I guess.
Like
a little bit less than 1/4 inch plywood.
It's like 6 millimeters.
6 millimeter plywood.
Everything, it's the nice Baltic birch from Russia.
Yeah, basically our
fancy.
shop tech, Scott told us please don't use MDF because it has a lot of glue and formaldehyde in it, and that isn't great for our ventilation. But we have
Only in
we have 2
California.
laser cutters. What?
Only in California. That stuff only causes cancer in California. Have you guys ever seen those warning labels?
No.
So really, it's like only in the state of California is this known to cause cancer.
Oh, really?
Yeah.
Oh, God.
That insulating foam has that all over.
Oh,
because that's what I
really?
was milling in grad school. But anyway,
no.
I did not mean to interrupt. It's just,
No. That's funny. Yeah, so we have 2 really great laser cutters. We have a Epilogue, a 120 watt Epilogue that will cut through 1/2 inch plywood if you wanted it to, probably. But yeah, so it's like a 3-foot by 2-foot bed, and we cut it to size and embedded all of our pieces in there. I think it's, right there. So this was all the pieces that we wanted for ours. And so I just selected this and exported it as an Illustrator file and just took it right to our computer that's hooked up to our laser cutter and hit go, and 10 minutes later it was ready. Yeah, we're super lucky at CSU. We have really nice machines and
yeah.
yeah.
I have a question. Sorry to
Yeah.
send you another trajectory.
No, that's okay.
I'm just curious. It strikes me like it's very easy once you start getting in this Grasshopper to, you become very lost, in a good way.
Yeah.
And things. Is it, I guess my analogy is like you start out with a sketch in a sketchbook, and then you go to the slab roller, and you make the thing you sketch.
Yeah.
Do you ever have an idea of a form and you actually just kind of you get to it really quickly, or is it always a process of once you start getting into the program that the result is always radically different than what your first preconceived notion? So I guess sorry if you covered this in your lecture.
No,
but
yeah.
I'm interested in the order of decision making.
Yeah, and I think I use it for both. Have started using it for both. I think I started when in Syracuse before I had access to big machines or knew how to use them. I would just sketch in Rhino a little bit. And Brooks, you talked about that too. Like just using it as like a sketch tool. I still do that. I use Grasshopper too. I find now that I know what it does, and I know that it has that little bit of I can add just a little more complexity or variability. I'll go to it for little things. I was talking to Todd about this. He was wanting to fillet a curve. He had 2 circles, so we could build 2 circles. And I can go into Grasshopper. And so I will use it kind of for both. If I have an idea like this, I will sit down and kind of know that it's going to get long and big and go for it and just kind of map that out. Sometimes it gets bigger than I anticipate. Oftentimes I'm just thinking about things and I'll use it and I won't even save them because it's just 3 or 4 nodes. And that's something I think I would like to get better at. I talked to Andy Brayman about how he does Grasshopper, and he makes his own little modules. So you can kind of write your own little nodes as in there and then save it as its node and bring it back for a different thing. So if you're making mortise and tenons a lot, you can write a little node that just you input where you want it and which angles, and it'll just do it. And so you can start building these little tools, kind of like how you're using just tools, but it's in there you're building your own tools. But I will often, if I wanted to, take these 2 curves, and we were talking about, we were talking about filleting them, like making a rounded edge between them. You can do that, fillet. And so it asks for the two curves, and then it asks for the radius. And so I can make a little slider. And so this is, I was just kind of showing, and it's like, okay, if you want to know like your radius between, let's see, oh no, that didn't work. Oh, now my demonstration's not going to work. But something really simple of like, oh, I think I know what I can do. But yeah, no, so I do use it for both. Like I will use it just as a little side moment for sketching, but then also sitting down and kind of knowing. And then sometimes it blends into itself where I didn't think it was going to be this long thing. Sometimes it is like the studio a little bit where you have this idea and you think it's going to work out great, and then 2 hours later you have this really like mess of a thing and you're like, I don't think I'm going to make this. This is not going to work out the way I wanted it to.
Yeah.
And those are frustrating days for sure, I would say. Maybe this is what I want. Yeah, so like we were taking a, just two curves, and Todd was asking me, oops, I don't want to do that.
Who's Todd?
Todd is my boyfriend. He's
Yeah.
sitting right over there. He was asking me, what, sorry, let me just hide some things. But he was asking me, how do I fill it? I want the round between these two curves. And so I showed him how to do it in Rhino, but then I said, hey, there's this really cool thing. What if you wanted to do it, like, what if you didn't know what you wanted that blend to be between those? And so now you can take it into Grasshopper, and now I can just try a bunch of different things. And so I can see that blend if I want it really soft or kind of sharp, and look at it that. So I'll do that too. Like if I just want to check it out, and even just by feel, like, oh, right there, I want it there. And then I'll just bake that and go. So yeah, I'll do it both.
Are there
Yeah.
other tools that people use that are just as simple?
That are like in Grasshopper and Rhino.
Oh, and Rhino, other than Rhino. So, I mean, Rhino's $1,000,
It-
and you have to buy upgrades, and
Yeah, there are there's tons of free software and cheaper software. If you're at an educational license for Rhino is only $200.
Well, some places will be like 95.
Some cheaper, yeah. So
And all of the Autodesk software, if you're affiliated in some way with a school, it's free.
Yeah. No, so there is so many. Who was telling me Tinkercad? Someone was using
Mine
Tinkercad.
still works.
Which one?
Oh,
Do you have one?
so Rhino used to be,
Oh, it used to be open. Is it no longer? I think they just
Yeah.
made it out of beta. It was in beta version for Mac,
Like
and so it was
7.
open
Oh,
source.
we don't know.
like, when I started
sure there
using it,
is.
like, it was free.
Yeah.
And, like, literally this past year, I was like, no.
Oh, you got to
I
get
have
an
no idea.
educational license.
We'll
It's
find
really
out.
cheap.
Yeah, I know.
But yeah, so no, there's so much free
Yeah,
free
right.
software out there to use. I learned on Rhino, and so for me,
That's
and
true.
I'm affiliated with a school, so I can get it for
Yeah.
myself for fairly
Yeah.
cheap.
And then there's like, I recently did a workshop and we were using 123D design.
Oh yeah,
And that's like,
pretty good.
oh yeah, I mean, it's like Rhino, like, yeah, exactly,
Yeah.
Rhino Light. Like,
Yeah.
I mean, also at the same time, I know that I use Rhino for like maybe a 20% of what it can do.
Oh yeah,
But yeah, for the most part, like, I found I was able to do a lot of stuff still with 123D design, and that is like $10 a month or something. And so it's like really easy to try out.
right.
So if you don't like it, then, just don't renew. But,
Yeah, Rhino was made by, or it was invented by boat makers. So
Yeah.
it's meant to design like
crazy complex, like
big
boat
things. If you
curves.
look, actually, if you've ever done this on the templates, like it asks you what your template, and it's like small objects, inches, small objects, millimeters, large objects. And if you read what small objects inches says, it says anything less than the size of a semi-truck.
Yeah.
And so that implies, though, that if you picked large object inches, you're maybe going to design something more than a semi-truck size.
I wanna see
And
that 3D print.
There's, and then Rhino, the thing that you do have to, there are plugins that you have to buy, but Grasshopper is free. There's lots and lots of plugins that are free, and people are doing some pretty amazing. It talks with Python really well too, which is just a normal programming language. So, but yeah, there's so much stuff out there, and a lot of it is open source and free or very, very cheap and easy.
Yeah.
Brooks, what are you making over there? You've changed.
Oh, yeah, it
Making
did.
something else.
So I'm making a salt and pepper shaker.
Oh.
This is kind of the final one. I cast them in two parts. So they're cast individually, just like this. And so I'm a Dallas boy, and manners were.
What does that mean?
Well, that means like manners were ingrained into me at a very
okay.
early age, and you always pass the salt and pepper together.
Oh,
It's
okay.
like that's a general rule. The more you know, if you don't know that, it's a polite thing to do. But so I wanted to actually make a salt and pepper shaker that's like one form. So half of this is for salt, and then the other half is for pepper, and it's two forms. 2 holes at the bottom. There's a wall that goes down the center, and so I cast them, cut out one of the walls, and just kind of splice them together. But that's what I'm working on over here. So I just assembled that. But you know, just to chime in on something that was being said in regards to the program. So I guess for me, like trying to think about how the programs like influence my stuff. For me, it's always kind of a very physical response. So like I use the programs as a means to an end to like create a design. So like I very rarely, like I don't use Grasshopper. Like it's not, I use other different plugins that'll enable me just to make the objects that I want. But I'm more influenced less by the programs and more by like the process of actually taking it out of the computer. Like I was working on this vase that was a tall shape, and the mill couldn't mill it out.
Right.
It was too tall. So I divided it into different sections, and I just found those pieces to those sections to be so much more like interesting than the actual original form, and I actually never made the original form. But those pieces then became like Lego blocks that led to like 13 different forms.
Oh, cool, yeah.
And for me, like that's kind of where my inspiration comes from with working with this technology, and I love what you were doing with Grasshopper, and I find it like super like interesting. But yeah, it's so interesting how this technology like influences the work in such different ways, whether it's in a very physical way or very like in a very programming sense.
Totally. Yeah, and I mean, like for me, I don't know, with my math background, like I'm already kind of accustomed to thinking in this really like logical step way. Like that's how math works. Like you have to do this thing to get to this thing, and there's rules, and the steps have to make sense and mash together. And so, yeah, like for me, when I learned that Grasshopper existed and what it was, I was like, I need to be doing that. That's why I didn't know that, but that's what I was after in this world, kind of. And totally, like but I like how versatile it is and how you can just get so many different things out of it. And yeah, I mean, and like,
Take that a step, excuse me.
oh yeah, no, sorry.
Take that as another step. So are you just intuiting, when you look at form, you know, you envision form, are you intuiting Grasshopper, I mean, in your mind's eye?
Oh.
Like, because of your inclination to be towards numerical logic, is that your just default position where you're kind of visualizing it in a program sort of way?
I don't know if I can do that yet, but like things like we did a tour of Zahner, and where Joe Cam works, and they were showing this facade of that they're working on for Cornell, for some Cornell museum, and they just described like what they were doing, and I kind of immediately thought, I was like, I could program that on Grasshopper, but then I found out they did program that on Grasshopper, and so then it's like this world where I'm learning. Yeah, I think it goes a little bit both ways. I think sometimes yes, but also, I mean, I'm still like researching in different ways and finding different things and visual. I can't say I can just like see it right away, but yeah, some things, and definitely some things lend themselves more. Like I was making these cups that fit to the hand and they tessellate, and those were all just in Rhino clicking, and like that one was one where, yeah, it just didn't feel necessary to bring it into Grasshopper and do that.
Well, I'm wondering whether at some point you'll, I know this sounds a little hokey, but you
Yeah.
dream, whether you'll...
Yeah, maybe. Because it's like a language.
Yeah.
Yeah, totally. It's like when you, yeah. I mean,
The more time you spend with it, the more ingrained it gets in your imagination.
when you
did
have
you feel like that,
spinning
Grant, when you
dreams
were like right in the
going on
middle?
wheel.
of your
Yeah,
piece?
for sure.
What?
Like you were dreaming in Grasshopper? Like all you could see was Grasshopper definitions?
It was more
flowing?
like I can't figure out how to make this thing work because I couldn't I couldn't get those the waffle to like generate off the form I made.
Yeah.
So it was more of a nightmare.
And more of a nightmare situation. It's like you have a math test the next day and you didn't study or something.
Yeah.
That kind of nightmare.
Yeah.
Grant, what are you doing?
I'm just taking the mold apart over here.
Nice.
I'm trying to speed it up a little bit.
No, I think it looks great.
707.
We found like this is number 4 we've ever cast.
Yeah,
We didn't even try this at home. And we've been we're not supposed to. But yeah, it comes apart really.
really pretty nice.
I think we made some decisions like we didn't have keys, and I think those were like we didn't know it, but that's a really good decision because I don't think I'd be able to take it apart as quickly.
Yeah, I think that's right. Yeah, everything has kind of come apart really nice. We made some decisions too, like we made that each mold part is 2 inches thick, which is probably a little thicker than you might normally try to make a mold, especially in digital where you could have the ability to make your mold exactly 1.25 inches away from your actual part everywhere. You know, you have all those possibilities, but that was a conscious decision where we kind of were thinking about, I don't know, just what a thicker mold would give us, more casts maybe, and of the plaster, yeah, just easier to come out. We knew we were milling in a little bit, so yeah. Totally, yeah, right. So I think because we were milling into them, we just made the whole thing thicker too, just to kind of give ourselves some room. Yeah.
Voila.
Nice.
Ooh, it's pretty. No one else here.
I'll take that mold from you.
Thanks.
Thank you. You guys are awfully quiet.
Does anyone have any more questions? Or?
I know that there's something going on in those brains.
Does anyone have something we should
Grasshopper.
make in Rhino? Yeah. What do you guys want to make? Could start modeling things.
Actually, I have a quick question.
Yeah.
So,
Oh.
because I saw your definitions can get really complicated. So did you say that you could label?
Oh, yeah, totally. So here, let's make Grasshopper big. So basically, I'll delete that. But yeah, you can label, and I started to a little on this definition, you know, labeling things like this is the part of this is just the printed strap holder part. So that was the part that made all of those. Let's see if we can open up another one, maybe. Like, maybe that is, well, I'm trying to find one that's a little bit more organized. But that's also what I was talking about. That's something that I don't do well. I mean, this is kind of like my studio practice is not super organized. My studio is always a mess. And I tend towards that. And so it definitely takes a lot of consciousness. I'm trying to, this one's a little bit better. Trying to organize. So yeah.
30 minutes.
You know, this one, it's like that's what this part is doing. But this is what I was talking about. Andy, you can condense that. So I could condense that into one module that like has different inputs. And then I can save that. And then if I want that same operation in my next one, I just bring that in. And that's something I'm kind of working towards. Yeah.
So, talking more to the software process we have, let me tell you the parts I understand.
Yeah,
so far.
yeah.
Grasshopper helps automate the creation of lines and curves in Rhino. And then in Rhino, you export it as an Illustrator file. In your case, that was a flat Illustrator file. But in another case, like for the curved pieces, what are you exporting?
So Rhino will export in lots of different ways, and it'll export STL or an OBJ, which is a lot of what these other DXF, which is a lot of what it would export pretty much, I would say, to most CAD programs. But to get it to mill, so we're using a CNC mill, just like that one. And to do that, you need some CAM software. So this is what's called CAD software, which is computer-aided design. And then you need CAM software, which is computer-aided machining software. And so CAM software, again, it can be cheap and it can be expensive. Like Rhino for educational license is $200. Rhino CAM, which is its own CAM software. The professional version, which is the one that, you know, like I think, I don't know, boat makers maybe are using, like the really heavy duty is like, I think it's like $10,000. It's really pretty pretty expensive, but it does a lot. But you know, Rhino will talk with other CAM softwares too. So then you need this CAM software, and then you run it through that, and you do all the settings where you tell the mill how to mill your piece, and then that gets exported as G code, and that was what like Keith is writing his own G code because of kind of how DIY and it can get complex, and I'm sure are more, but like this one is just moving in these curves over and over again. And so he's writing his own G code for that, but you could imagine that if you're milling a complex form and you don't want it to run in, and then you have this bit size that is its own thing and it has to interact with your geometry, that it gets very complex. And so it's just a different piece of software that interacts with that. But yeah. So that's that one, but yeah, then to a two-dimensional thing, Illustrator will is fine.
Anything that generates a vector.
Yeah, anything that's vector generated. And it talks well with Illustrator. You can build in Illustrator and bring it back in. You can build things in other, you can get other CAD files or other CAD programs and bring them into Rhino. Yeah.
And there's CAM software that's, like I want to start learning, it's called Fusion 360. So all the Autodesk software is free if you're through education. And it has a modeling component, but it also has a CAM component built in. And it seems like I can select all the different sort of, like we use this Mach 3 interface for our Techno or K2, and it's there. So
Yeah.
I just need to see how well it works. But
And something like we did a little 3D printing I did with Dell last year, and something that I learned, Dell at some point told me, hey, I think you should write the G code for our 3D printer. And my mind exploded because I don't know computer programming. Like I was a math person, and it was crazy. But then he's like, no, just look at G code and see what it is. And all it is all these machines are doing its points. So it's saying go to X equals this, Y equals this, Z equals this. Go to this point, go to this point. So it's really this like, the actual thing that these machines are taking in, the G code, is exported as just a text file. And so it is really like, it gets complex and there is some more complexity, but it can be this really, really straightforward thing. And so like, for me, that was really important in understanding, okay, yes, it gets complex and people are writing programs that are really powerful, but the thing that comes out, like I understand fundamentally what that is telling the machine to do. And that was like a really important moment for me, at least, in just like, I don't know, demystifying some of this stuff and feeling like, okay. And seeing people like Heath, who has justely taken, a kit and then just done what he needs to do to make his work is really exciting to see,
How are we doing on time?
We're almost up, but real quick, I just pulled this piece out of the mold. And these are my workshop travel molds. They've been used very well. So there's a lot of cleaning up that has to be done. But again, that original cookie cutter where I cast a slab of the same porcelain clay with a blue colored grog in it, then cut it out and then embedded that into the mold, and then cast that. You guys can pretty clearly see where that blue grog is. And I really, I'm really fascinated with that like colored grog right now. I'm liking when the surface of my surfaces start to look less like a glaze and more like a stone, or just something that's a little like less familiar. Maybe it's not so easily recognized as something that is clay. But as a side note, I do have some like demos of what that colored grog looks like. This is a little linoleum-like, or like those gym mats that you play on as like a high schooler, or not high schooler, as like a grade schooler or something. But yeah. So then there's just a lot of cleanup that has to happen.
Yeah.
But yeah, how are we on time?
Yeah, I think we're almost
Are we done?
just about up, because then it's like 3:30.
Yeah, 3:30, and then I'm at 4.
What?
I know, that went quick.
Cool.
Yeah, well,
Questions?
thank you guys so much.
you.
Thank you guys for coming. Yeah. Mm-hmm.
Nice.
Yeah.
Yeah, of course. It was my
Yeah.
mic so much.
So depending if you're working
Yeah,
with
absolutely.
ABS plastic, you can take like an acetone rag to it and smooth it out. That's not what these are. So this is a laminating resin that you would use like on a bar top, like Envirotex or something. It's a 2-part resin. It takes a while to dry, but you want to make sure you get a sandable resin. I actually don't do that anymore. What I'm doing now is I just make the mold and then I wet sand the mold immediately after I make it. And yeah, it's so much smoother because this just takes, it's an extra step that's going to add like 2 days at least to the process. And if I can avoid that, I do. So yeah, thanks.